So today what we're going to do is we're going to do Z and T tests. And most of the tests we're going to do today are going to be t-tests. And the reason why we're going to do t-tests more often is because if you know a lot of information about the population, meaning you know the standard deviation, generally you don't need to test to make sure it's correct because you know a lot. So a lot of these are going to be t-tests where we have to take a sample and use the sample's population, which means we use a slightly wider curve. We do need to check conditions. The first condition we always check is if it's normal, and we can do that by it either being bigger than 30 or the fact that the population is normal. We're going to assume in this case the population is normal because our sample is definitely not bigger than 30, so we're going to assume the population is normal. The next thing that we need to check is we need to check independence. We're going to assume that they have more than 180 workers for this assembly line, which probably is a good assumption to make. So again, it's probably, we have to make sure the sample is not greater than 10% of the population. And the last thing that we need to check is we need to check that they were randomly selected, so that we have this randomness. And they were randomly selected because it says a random sample. So that is good for us. The last thing, if we're going to use a t-distribution that you want to check, is you want to check for no outliers. Now we can't check that in this case, but in some of the cases where they give you a data set, you need to use the 1.5 IQR rule to check for these outliers because a t-test can't handle outliers. We can't have any outliers. We're going to assume in this case we don't. And this, they want us to test. They want us to do a two-sided test, and you can tell it's a two-sided test because it's not equal to. So that is the biggest thing that we want to do. So we're going to do this two-sided test, and they found that they have a mean of, for their sample, 17, and the assumed mean was that the population, or that the satisfaction of these workers would remain the same, that they wouldn't increase. But we found that when we took a sample that it looks like the satisfaction did increase. So we're going to quickly see, like, should we accept it? And again, they didn't give us an alpha value, so let's say our alpha value is 0.05. Okay. And we're going to do a two-sided t-test, so it's going to look something like this, and we're going to have a little bit on this side and a little bit on this side, and we have to see if that is higher than 5%. To do this, we first need to get where it falls on the graph, so we need to figure out our z. So we're going to do 17 minus our mean, which is 0, over. Now, if we had the population standard deviation, we would use that, but we don't, so we have to use the statistics. So that's 60 over the square root of how many we took, which is 18. Okay. We're just going to throw that into our calculator. So we would find that we would have 60 divided by the square root of 18. So we'd have 17 divided by that answer. So our statistic here is 1.2. Now we need to use that on a t-table instead of a z-table. And the reason we're going to use a t-table is because we have a sample and we don't have the standard. Now if you remember, our t-table is a little bit different than our z-table. Our t-table starts with degrees of freedom. So we're going to start by looking at the degrees of freedom. And the degrees of freedom that we have for this thing is 17 because it's 1 minus the number that we have. So we have 17 degrees of freedom, and then we just have to look for that z-score that we found, which is 1.2. So we know that the tail on this end would be about around 10 to 15% on this side. So if it's a double, it'd be around 20%. So this would tell us that our p-value is around 20%. Which is definitely bigger than our alpha value. So we would not reject the null hypothesis. So since I wouldn't reject the null hypothesis, I would accept the null hypothesis, and that's kind of how the two-sided t-test would go. We could do this on our calculator with a little bit more ease. We just go to the stat button, and then we go to tests, and then we go to one sample, or we go to a t-test. You have a choice to use data or stats. For this, we just have stats, so we're just going to go to stats. Our assumption was that our mean was 0. 17 was our sample mean, and we wanted 60. And we had 18 workers, and we want it not to be equal. We don't want it one-sided like that. And then we just hit calculate. And as you can see, we got the same t-value, which is 1.2, and then it can do a p-value a little bit more accurate, so it looks like it was a little bit higher than 10 like we thought, closer to probably 12, and with both sides it's 24.5%, which definitely, again, approves our alpha, so we're good. Another nice feature that's kind of on the calculator that you can do is you can actually draw these things to get a better picture idea. So instead of just hitting calculate, you can hit draw, and it will draw that normal curve or how it would look. So like you can see kind of where it shades. So it shades like that 12% there, and then it will start shading on the other side of the two-sided test. So you get kind of a better idea of what your distributions will look like. But that's essentially how a t-test will go. A t-test will do the exact same thing that we did with a proportion, except now we're just using our t-stats. And with our t-stats, we just have to do degrees of freedom and remember that outliers really, really affect us. So if they do give us a data set, we do have to check for outliers and go, does anything not fit the 1.5 IQR rule? Try the different p-tests today. If you have any questions, please ask.